Hi, my name is Sam. I'm a senior customer success manager at GitLab, and today I'm going to show you how to secure your premium applications on GitLab. All right, I'm going to share my screen and kind of show you through a secure app that is solely using features on GitLab's SaaS premium offering. So first of all, this is my project. As you can see, it's called Secure Premium App. It is actually surfacing this page's website called Sam's Blog, and it's just a basic Bootstrap template deployed to GitLab pages. So pretty simple, nothing too complex and crazy, but this project does leverage a lot of different security features to ensure that you are actioning any security vulnerability findings that you have found through our security scanners. What many people don't know is that GitLab offers a full suite of security scans on the premium tier as well as on the ultimate tier of GitLab. So, for example, SAST, secret detection, container scanning, we have several security scanners that are available on premium as well as on ultimate. The catch here is that Ultimate offers a full suite of vulnerability management tools, including a vulnerability report and a security dashboard to actually action vulnerabilities and findings, create issues from findings, etc. But on Premium, you can still leverage security scanners as well as build your own security by incorporating third-party scanners into your GitLab CI pipeline. So today, I'm going to kind of walk you through how I choose to action vulnerabilities found in my merge requests through a kind of on-the-fly merge request approval rule that I create using our Python GitLab API. So again, this is the website, pretty simple. All the contents are in the public folder, but I'm going to walk you through the gitlab-ci.yml file here. So it's a pretty simple YAML file. Again, it has all the stages, build test, one that I created called process vulns or process vulnerabilities, the review, which is where the review app is created to actually show the changes to the site, as well as the deploy stage to deploy the changes to my production. So in my build stage, not much goes on. Again, just like some static HTML, CSS, nothing too fancy. But I do have a secret detection job here. And essentially, I incorporate the secret detection job because I'm overriding the secret detection job that comes out of the box, right? So in this job, I create an artifact, or I save an artifact, which is simply the GitLab secret detection report JSON file. This JSON file is very useful because it contains all of the vulnerabilities found after the security scan. So in this case, you would have to override like your SAST or any other security scanner here to save the artifact, because essentially when you're saving the artifact, you can access it in a future stage and future job for post-processing. So that's why I'm saving this artifact here. Then I create a job called process secret detection, and this is in my process vulnerability stage. So essentially here, I am using Python, so I include the Python image. And I say that this needs the secret detection job, which in this case, it means we need this job to have passed successfully. When the secret detection job runs and succeeds, it's essentially marked as succeeds, even if it detects vulnerabilities, right? Which is a little bit strange. You would think we'd fail that job, but actually we succeeded in the job running properly and actually executing. And then you can process the vulnerabilities from the successful job afterward. So we need that job to have succeeded so that secret detection did run properly. We also do need the artifacts from this job as well, which, as we remember, we saved up here in our secret detection overwritten job. Have a quick before script. This is just a pip install of Python GitLab. This is so we can access the Python GitLab API to make calls and interact with our, you can interact with anything within GitLab, your group, your project, whatnot, but we need to install the API just like we would in the import Python GitLab line well, actually you would do this on your local machine and then you would import the API in the Python script and do whatever you need to do in your script. So in this case, this is the script that's running essentially what I would write in my terminal because I'm on a Mac. So I'd write, Python 3 process vulns .py. That's the script name that's included here. as well as passing in the path to the JSON file. In this case, it's just the GitLab secret detection report.json. We're going to need a project access token to access details of the project. You can create that within your project settings and save it as a variable. The CI project ID. So this is a variable that's actually specific to that you can access because you're in the GitLab CI file. And finally, the CI commit SHA. So I'm using these because they're actually used in the script. We're passing them in as arguments, but they're used in the script to access the merge request information. I think I wanted to pass in like the merge request IID, but I wasn't able to do that for this case because the only way that that variable actually has a value is if I make this an only run on merge request job. And if I do that using rules, none of my other jobs will run, which I do not want to do because I want these jobs to be able to run in my main branch as well, not just on merge requests. So I do have to do a little bit of hackiness by passing in the commit SHA and the project ID, which we'll see in the script as we go through it. So anyway, passing in my arguments to my script, and then the script will run, right? This is the command to run a script. And then finally, I have my review app. So this is my review app job, where essentially I'm giving the name, which will be review / whatever the commit message is, as well as the URL for this, where I want to be able to preview my changes before I push them into prod. I do this on everything except main. Obviously, I don't need to create a review app if the job is running on my main branch, because at that point I am deploying to production. It's over, right? And then finally, I do have to call this job pages because that's just a finicky thing with GitLab pages is the name of the job. It doesn't need to be pages, but this is my deploying to production job. You can tell because it's in the deploy stage. This is a manual. So when manual, this is a manual job. So this will only be triggered when I or someone with the correct privileges, in this case, I'm the only person in this project, but when I trigger the job, we will deploy to production. And you can see the production environment name production. This is a protected environment, which we'll go into in a bit. And it only runs on the main branch. So whether it's main, mainline, master, whatever your semantics are, basically your default branch name here. It only runs on that because at this point, again, you don't want to have a manual production job in your merge requests. That doesn't make any sense because you're committing rapidly and repeatedly to your merge request. So you have no reason to have a manual production job only on your main branch. And then finally, I'm including all the different security scans down here, including this template for security / secret detection, which is, we're only covering secret detection in this case, but these same principles apply to other scanners as well. You can see that this is actually what's going to run the secret detection job or give the information to run the job. But again, the job was overwritten up here just to include the artifact path. That's a quick rundown of our CI.yml, and just to kind of see what that looks like, let's hop over into our editor just to see a visualization here, especially with that needs keywords. That's something that is helpful to have context on. So when I visualize, at my build stage, again, I had nothing going on in there, but perhaps if you were building, your application, that would be in the build stage. Since I included SAST, container, and secret, you'll see everything was included in the test stage, right? Because I included the test stage in my list of stages, then I also included my secret detection as a job type, and I overrode it. I did say that the process secret detection job in process vulns needs secret detection. So you can see that this line is giving that logic there that it needs secret detection to have run successfully to run this job, or it will not run, period, right? No vulnerabilities needed. Or rather a failed secret detection job, which is a little bit semantically different, but kind of serves the same purpose, right? This needs to succeed for this to run. And then my review app job and my pages deploy job. So this is the full pipeline, right? Visualized here. Great, okay. So let's dive into that script we were talking about. Process-vulns.py. It's always fun to go through some code live, but let's dive into the logic here. Essentially, again, what happened was we saved the results of the secret detection job, right? The results of that is a JSON file with vulnerability information. So keep that in mind. Now you're probably wondering, well, what do I do with that? I'm scanning and there's no logic in my pipeline to stop the pipeline, to incorporate reviewers at a specific time. Well, how do I action my scanners results, right? So again, you got your classic import statements. We're using the GitLab API to interact with the merge request. So basically the logic that I want to have here is I open a merge request and I introduce a violation that will trigger a vulnerability in my secret detection scan, right? What I want to happen is I want to essentially require an approval from an author, or perhaps a group of authors, to approve the merge request if a critical vulnerability is found. I can get more granular and say, if secret detection detects a critical vulnerability, I want to have someone approve this merge request. This way, you can protect your environment in such that you don't merge anything that hasn't been approved, right? Or you need all the approvals, all the required approvals to be met. We're essentially mimicking a scan result policy here. Scan result policy is an ultimate feature where you introduce a required approver from a group of approvers to a merge request if a vulnerability is detected. This solution is not a replacement for the scan result policy as of today. Scan result policies are far more powerful. First of all, this requires a lot of customization. Also, this file does live within the same project as your application. There might be ways to kind of get around this and include files from different locations, but that's out of scope for this video. As well as this is not necessarily looking at new vulnerabilities detected. It's not smart enough. It's looking at just the JSON results from the merge request, and it's requiring the approver, and that's kind of where it's at the end, right? We're not dynamically removing approval rules when the vulnerability is fixed, right? Once we get that approval, then we're good. So this is an extremely intelligent script. There are limitations here, perhaps limitations in my knowledge, perhaps limitations in the product's design. Additionally, the vulnerability records here, you can't view vulnerabilities in the merge request widget, which is hugely helpful to action. Also, you're not creating vulnerability records that can be tracked over time and looking at the health of the application over time. You don't have any of that context or tracking or actioning from the vulnerability report, which is a huge feature in GitLab Ultimate. So caveat here that this is not a replacement for scan result policies or vulnerabilities in GitLab Ultimate. It's just a way for you to have a baseline way to action vulnerabilities found when using GitLab Premium scanners. Now that caveat's out of the way, let's dive in. So essentially, I'm loading in my JSON file. I'm doing a little bit of hackiness there to make sure that we have the results of the file. I also tested this a lot locally, and this project should be publicly available if you want to take a look and grab it for yourself. We're using Python GitLab, pretty easy to use. So let's dive into the main function so that we're not going function by function and kind of seeing the more larger scale picture. Essentially, again, I'm taking in all these arguments that I passed in from my gitlab-ci.yml file, right? The JSON file name, my project access token, which is, I believe, saved as a variable in my settings here. The project ID and the commit ID, right, for the commit shop. All right, great. And then I'm calling load report details with the JSON file name. We'll dive into what that's doing. And then I'm going to report the vulnerabilities and save them to a variable called vulns. And then I'm going to determine vulnerabilities with the vulnerabilities found. Great. All right. So, and then this GitLab equals authenticate GitLab is just me kind of like logging in and essentially getting access to my project information with the Python GitLab API. All right. So kind of diving into here, the first thing that is called is load report details, which we did up here, just loading in the JSON information. And then from that report, I'm grabbing the actual vulnerabilities, like value from the vulnerabilities key. So if you look at JSON files, you'll see it's like key values. So I'm just getting the vulnerability details from the report functionally. I'm authenticating with GitLab. So here, sending in my project access token, and I authenticate with the authentication function that's already built into Python GitLab. And then I return my GitLab little variable, I suppose. GitLab instance. I don't want to say instance because it's a bit confusing. So, all right, great. And then determine vulnerabilities. This is kind of where the magic happens. So basically, if there's no vulnerabilities found in that file, in that JSON file, to say that would be the case of secret detection passes, and we're passing in the JSON file, and it's just empty. There's nothing in there. There's no vulnerabilities detected. I log no vulnerabilities detected, and you'll see that in the merge request, in the pipeline logs. When the pipeline runs, see no vulnerabilities detected, we're done. Otherwise, we do want to log the vulnerabilities. So we call this log vulns script. So I write vulnerabilities detected, and then I basically just spit out the JSON information. It's probably not the cleanest thing, but you can log however you like. Now I want to action the vulnerabilities because they do exist. We want to handle them. So for every vulnerability in this list, I'm going through and I'm checking its severity. So in this case, I'm checking if the severity in that JSON, right, is critical, right? So in this case, I want to handle critical vulnerabilities. I write that critical vulnerabilities are detected and there's going to be an approval required. That's what I want to do logically here. I create a critical vulnerability approval rule name. This is because I'm creating my own approval rule kind of on the fly. So in this case, I want to call it critical vuln detected. Now this is kind of where the ugly part happens. I'm just trying to get the object for the merge request, right? So I'm getting my project information because I passed in my project ID from my GitLab-ci YAML. Remember, if we saw that script and then we saw Python 3 run this script, one of the arguments was the project ID. The merge request ID I get through passing in, or by calling this get command where I pass in the commit ID and the merge request, as well as the first item in the merge request list, and then I have to get the IID. So that's how I'm getting my merge request ID. It's a little bit funky, I know, but this is how I was able to get my merge request object. The merge request is the merge request get merge request ID. So essentially, I couldn't get the merge request IID as a CI variable, as well as predefined CI variables. You'll see that in the list, and you'll think that's a great idea. Like I mentioned before, you actually can't get that value, or the value is not assigned to anything unless you write that this only happens on merge requests. But you don't want this to only happen on merge requests because then every other job will not happen unless it's also marked a merge request job. Kind of a weird functional thing with GitLab, but that is the case. So it's just a hacky way to get that merge request object and the merge request ID using the SHA and the project ID. Basically, I'm checking if the rule already exists. Where I go through my merge request approval rules and I get the rule's name, which again was that critical vuln detected. And if it does already exist, then I set this exists to true, and I don't do anything because the rule already exists, and having duplicate rules will throw an error. If the rule does not exist, which is, hey, vulnerability detected, critical vulnerability detected, rule does not exist, let's make one. Merge request approval rules create, and then I kind of do a little create here, put in the vulnerability approval rule name, which I set up here as critical vuln detected. I'm requiring one approval, and I am giving a user ID to approve. This is actually my user ID on GitLab, but you could put a list of people as well, our list of IDs. All right, that's actioning vuln. So now I've created my merge request approval rule from the critical severity. Again, this is not super all-encompassing. You would have to have like a switch statement with different criticalities. If you only wanted, only for secret detection, you'd have to specify the type of scanner that detected the vulnerability. It becomes kind of a big mess. Maybe something you could do, but again, we're just looking at critical vulnerability detected and we're creating one approval rule for it. It's not as extensible or as usable as a scan result policy feature. All right, so that's action vulns. So we're determining vulns, and then we're actioning the vulns. That's it. We've created our approval rule. So if we do introduce a security violation that is a critical one based on CVE and whatnot, This is the merge request approval rule that will be created. Awesome. And that runs in our CI.yml. Let's see it in action. So I actually took the liberty of creating a merge request here, where I added a personal access token. This is going to flag a secret detection violation. So in this case, I added, oh no, a PAT appears, personal access token appears. And this is a fake personal access token. You can't actually access anything with it. It's just the 20-letter string prefixed by the GL pat dash, which is how all of our personal access tokens appear, and that's how we can flag a GitLab personal access token, right? And you can specify certain JWT tokens or AWS different authentication token regexes. You can specify those and say, hey, these are some certain patterns to look out for through regex, and flag them as vulnerabilities as well. However, this is a GitLab personal access token, and we don't want that, right? So we can see that the pipeline ran. We're adding the personal access token. We can kind of dive into what the pipeline looks like. As we see, secret detection did pass. So we drill into this job. Give it a moment to load. Great. So we had one leak found, obviously, which we don't have any details on in here. If we were on GitLab Ultimate, we would see a secret detection detected a vulnerability. It's a critical vulnerability. Here's all the details. This is where it's located. Here's what you can do to solve it. All this great context. But unfortunately, we only see leaks found 1. And the job passed. So if you're doing this without any script to guardrail or add a merge request approval rule or anything like that, you're getting no value, right? You're just scanning and you can check the box that you ran secret detection. But there is no stopping this vulnerability from going into production today. So let's back up and look at process secret detection. This is the job that we created with our Python script. So again, we're doing pip install Python GitLab just to make sure we have all the packages necessary to run the script, and we're running it. We see that we're able to authenticate successfully, which is important so we can interact with our project. And we're spitting out that vulnerabilities were detected, right? Because the file is not empty, the JSON file, we're able to say vulnerabilities have been detected. Here's all the information. It gives a lot of details. See that the category secret detection. There's no logic around that in the script right now, but the important thing to notice is, again, it gives a lot, but we were looking at severity and we're looking at critical. The existence of this severity critical is what's going to create the merge request approval rule. Since the critical vulnerability was detected, the approval rule was required. So we're going to go back into our merge request. Browse 1 approval from critical vuln detected. And I am the user ID we saw, so I am an eligible user. In this case, I'd only required 1 approval, and from me, but you could definitely put a list of people as well and require more than 1 approver as well. And you can also create multiple merge request approval rules. Again, you'll have to customize the script to do whatever your requirements say, but this is just an example. And then essentially I would have to approve this before I can merge the code. And that's it. Merge blocked. All required approvals must be given. And then security scans have run. It does indicate security scans have run, and you can download the results, which we can see in this case, if we wanted to download the secret detection, we can see the artifact information, and the JSON file will exist in that with all the vulnerabilities detected. But that is just an example of how you can create a merge request approval rule based on a vulnerability detected in your JSON file from our security scanners offered by GitLab, specifically in the premium tier. Again, this is not a substitute, nor is it as extensible as GitLab Ultimate. I have a fair amount of experience with GitLab Ultimate, and it definitely pales in comparison. However, if you want just a quick and easy way to kind of guardrail your merge request, this is a good step, especially if you're beginning to use GitLab security scanners in your premium environment. We do offer quite a few to our premium customers and even our free tier customers as well. So take a look at that and take a look at what scanners are available to you today. All right. So that concludes the securing your premium environment through merge request approvals on security scans. Hope you enjoyed. Again, I'm Sam, formerly known as Sam the TAM, Customer Success Manager at GitLab, signing off. And let me know if you end up trying this out and taking a look and seeing if it works for you. Thank you.